Welcome to the session 4 from the third chapter. Last session we discussed about the different switching techniques, the datagram, virtual network and the source routing, the three techniques we have seen in the previous session. So the next concept here is the bridges and LAN switches. So what you mean by the bridges means, for to connect it to Ethernet, we can connect it by a repeaters. But the repeaters can cover only to the maximum of a 2500 meter, which is approximately 2.5 kilometer. So this one is cannot be implemented for a little bit bigger size of a LAN. For this one, the alternative for a repeater is a bridge. Okay, so the bridge is it is also a multi-input and a multi-output, multi-input and a multi-input. So the connection of such kind of LANs through the bridge, we call this as a extended LAN. We call this as an extended LAN. So the definition, if you want to check, means it is an alternative for a repeater which will connect one or more Ethernets. Okay. So now how this will work? This is the bridge will also maintain a forwarding table. So what is a forwarding table means? It will be having the different host, nothing but the machines A, B, C, X, Y, Z, and the respective port number. Okay, so if you want to send a message to A, the A wants to send the message, which port it has to follow? It has to follow the port 1. Okay, so X, suppose X want to send a message to A, which port it has to follow? It has to follow port 1. Similarly, B and C and X. So A wants to send a message to the X, which port it has to follow? It will come to the bridge and it will forward to the port 2. Suppose A wants to send a message to B within the same Ethernet, then also A come to here to forward to the B, which port it has to follow? The 1 itself. So it will be given back like this. It will avoid going further when want to send message from A to B, B to C. This is a forwarding table that will be maintained in the bridge. Now, who will update this information means earlier as a normal human only, he will be updating this information. But when we think of the bigger LAN, the bigger size bridge, this will be maintaining will be very burden. So how they are developed bridges in such a way that they will only get updated automatically. How means we have seen in the previous session, the packet will contains the complete global address. Okay, so now by looking at the global address, the bridge will decide which output to send the packet on the address of the table. So here only it will be sent which port I have to follow, which port I have to follow. In the header only we will be given the information. In the previous VC technique source routing we have seen that one. So on that one the bridges will decide and it will forward to the respective port. Okay. Now initially the bridges will this table will be empty. As the packet arrives with the port number, then it will keep on adding. So for the further transaction it will be easy. So when the first it will be filled with the first packet, second packet, third packet, it can follow this port. So initially bridges will be empty. When the bridges is updating automatically, not by human. So this is the bridge. There may be a little bit of difference between a bridge, switch and a router. So for this one, I will take another session that will completely differentiate between what is a bridge, switch and a router. These three work in a different way. That one I will discuss in another session. Okay. So now when we think of the network, suppose this is the network, this is the different bridges which is connected to the some other network. Okay, this is a kind of a network. So if you observe, there is a loop here. From here, if I want to send the packet here, it may go here, it may go here, like that. The packet will be cycled here only. The looping problem may happen. Suppose from here to here I want to send a message, means the packet may cycle here only because of the looping problem. So this is some looping problem may arrive in a network. It's a very common in a network. The looping can be avoided. So the looping may happens because of two reasons. One, there may be a different administrator. Right, these bridges can be handled by another administrator, and this bridge can be handled by another administrator. There may not be any communication between these administrators. So they will only decide and they will implement. They will only decide. They will implement means, of course, the looping may happen. Another means by purpose only we can implement a looping. By purpose only we can implement a looping. Why means, suppose this path is lost, I can choose another path. The shortcut way, if you want to travel from one way to the another. The main block is lost means we can choose an alternative way uh, to reach the destination. So these the two causes for the looping. But of course this can be the some problem for a cyclic problem, and they may take much time. We have to build a network in a such a way that there should not be any cycle, means without any looping we have to construct a network. So the solution they come up with is a spanning tree. The spanning tree we will study in ADA also, spanning tree. So what it will means, we have to construct a network in a such a way that there is a no loop. The same network when we construct with the spanning tree algorithm it is okay. The same network, if you see, there is a no cycle. There is a no cycle for this one. By looking at this diagram we can write, but we need to follow a certain algorithm. So algorithm, how it works, how it is designed means we will see here. Okay. The first thing is, this algorithm used to set the bridges to agree upon on a spanning tree for a particular extended length, right? So this is the when different administrator is constructed means they will implement their own thumbs. To avoid that one, all the administrator they have to come to an agreement means we have to follow a spanning tree. We have to make sure that there is a no cycle should be done. There is a no cycle in our network. Okay. Next one is the bridge. Every bridge is identified by a unique ID, like bridge 1, bridge 2, like that. We have to give a bridge number for identification purpose. We have to give a bridge ID. Okay. Um, First, there has to be some route. From route only you can travel the different route. How the route is selected now? The route with the smaller ID will become the route. The route which has a smaller ID will become the route. So then how it will construct our next path means it will check which is near to that one. So it will check B2. It will check with the B2 and B3. Okay, which is smaller. So which one is smaller, it will go to that one, but both are at the same distance means again with the smaller ID it will select the next path. Okay, suppose B3 and this is the B1, B3 and B2 are there at the same distance of 2 km. So which one it will choose means it will choose the B2 based on that one it has the smaller ID compared to the B3. Like that it will choose the Next B2 to the next constructing to the next bridges is also on the same way. Okay, now how this information can be exchanged, how this will decide means by they will say exchange a configuration message, what we call it as a configuration message. Okay, a small packet they will exchange among these one to build this spanning tree. They will exchange a configuration message. So what this configuration message contains now, three things this configuration message will contain. First one is the ID of bridge, second one is ID of root, and third one is the distance between those two. Right? So this set of a configuration message will be sent. Among these bridges, this configuration message will be sent, and based on this configuration message, this spanning tree will be constructed. So that is will be the configuration message will contains these three parameters. Okay. Now we'll consider the example and how this spanning tree is implemented. Now focusing on the activity at a node B3. We consider the node B3. So this is the bridge ID 1, 2, 3, 4, 5, 6, 7. So these are all the bridges and these are all the connected LAN. A, B, C, D, E, F, G, H, K. These are all the connected LANs. So for this network we have to construct a spanning tree. Now we'll think of the we'll take as an example with the B3 forwarding activity, how it happens in the B3. Okay, first B3 receives a message from a B2 0 and B2. Okay, the ID of this B2 and the source which is not yet selected means it will send the source as the 0, and distance will be, and near to this one the distance is B2, like that it will send the configuration message to the B3. So since 2 is less than the 3, B3 accepts B2 as root. So here B3 accepts B2 as root. Okay. After this one, B3 adds 1 to the distance advertised by the B2. From B2 it is 0. From here to I want to forward to allow means I will update the distance to the 1. So thus it will send some configuration message to the B5, B2, 1, B3, B2, 1, B3. So here the order is missed here. B2 it is the root ID and 1 is the distance, and the B3 is the ID of the sent root. Okay, so this is a mismatch may happen, that B2 is a root of a B3 and the distance is 1. From here to here 0, from here to here it is updated to 1, and from B5 to B7 means it will update to the 2, right, like that. And the ID of the sent bridge, the sent bridge is the B3. So like that it will receive the forward to the B5. So the next is at the same time B2 will accept B1 as the root. B2 will accept B1 as the root because the ID is less than the 2 and 1 is less than the 2. So B1 it will accept as the root, and it sends next updated message. What it will send? B1 1 and B5. So it sends B1 1 and not B5 B2. It will forward to this one. See, every time the configuration message is updated. Okay, previously it has forwarded this message, but after discovering that B1 is the root, again it will send a this configuration message is updated. So B1 is my root with a distance of 1 and the my ID is B2, like that it will be updated. So when it receives this one, again B3 will update the root as a B1, right? That is the thing it will help us. And B5, what the B5 will do? B5 will accept B1 is at the same time, this one is also forwarding the message B1 0 B1. See, B5 it is receiving this configuration message also and this configuration message also B5. When it will think with the which is the smaller ID. So when we think of the 2 and 1, 1 is the smaller ID. So B5 accepts B1 as root. B1 as root. Okay, and this one when it B1 accepts this will be forwarded to the again it will forward to the which one it is connected to the B7 it will forward, and it will forward to the B3 also, which is connected to this one, that will be forwarded. So the next is B3 accepts B1 as root and it notes that both B2 and B5 are closer to the root. Then thus B3 starts forwarding the message. Okay, so now B3 it will think that B2 is also telling that B1 is the root and B5 is also telling that B1 is also a root. So then it will send it will accept the B1 as the root. Okay, so like that it is understanding, right? B1 is also, from B1 also I am getting message, B5 is also I am getting message, so there may be a chances of a loop. So this will be we call it as the edge graph. When that path is not needed, that will be considered as the edge path. Okay, so this is also edge path. Edge path we thought of it the only B3. Like that we think with the remaining bridges also. At that time every bridges will be sending this configuration message B7, B1, B5 to the respective neighbor, not neighbor, shortest distance. So based on the configuration message, it will decide which one is the root and which path can be implemented. See here the loop here happening, so this will be removed as the edge graph. Edge graph, this has been removed. Okay, so this is the spanning tree algorithm. The spanning tree, I will say the implemented here is in ADA. There is a shortest path algorithm is there. That algorithm is only the spanning tree. That algorithm can be implemented here only. Here we explained in a sentence wise. In ADA we discuss with the distance and a graph kind of things we will discuss. This about the spanning tree. Okay. Now a bridge should also support a broadcast also, and it has to support the multicast also, right? It is supporting broadcast is means within the same network means with this diagram. So it is supporting the broadcast, and how it is supporting the multicast from one network to the another network. If we want to traverse, it will choose a different ports, like that. Bridges is also supporting the broadcast and then multicast. That is a few things of bridge. Now the limitations of the bridge is there. The main limitations is a scale and a heterogeneity. Scale means, of course, it cannot connect So with the LAN only we will restrict our communication. When you think of the metropolitan area network, wide area network, this is not possible. The bridges. And heterogeneity means this bridge can be implemented only with the Ethernet to the Ethernet, okay, and 802.11 to the 802.11. So only this can be implemented here, but when I want to connect Ethernet to this 802.11, this will be not supported by the bridge. Heterogeneity, for heterogeneity network, bridge won't give the solution. Then we switch to the router. That is the next concept. So I told you I'll give the another session of these bridge, router and the switch. When we think of the scale, it will cannot connect the maximum distance. So the solution, they will give it as a virtual LAN. In short form, we call it as a virtual LAN. So here, virtual LAN, it will give a different ID. See, for this one, we have given the VLAN of 100 and VLAN of 100. B1 and B2 are two bridges which is connected. For this network, we have given the 100, and for this network, we have given the 100. Similarly, for this network, we have given 200, and this network, we have given the 200. Like that, within the network, we have made some another LAN, that is a virtual LAN. We have divided the network in a based on their ID, the 100 and the 200. So what it happens? When a packet sent by a host X, it will arrive at the B2. It will forward only to the W. Why? Which has the same ID. It won't pass to the Z. It won't pass to the Y. So it will forward only to the W. Okay, information can be traveled in the only here. But suppose Z wants to send to the W, which is not possible. Why? They have the different ID. So now Z wants to join the VLAN, means when it wants to convert 200 to the 100, of course it can be updated. So what it has to do, Z wants to join the VLAN 100, means we should need to change the one piece of a configuration on the bridge B2. It has to send the configuration message to the B2. So this ID, it will be updated to the 100. So at that case, this will become one virtual LAN. Okay. This can be the solution they are given to extend the scale. And about the heterogeneity, it is not supported by the bridge. Then we will switch to the router. That will be the next topic of this one. So in today's session, we discussed about the bridges, forwarding table, spanning tree. Spanning tree is important. With the think of the bridges, we can cover and certain limitations of the bridge.